All right, ladies and gentlemen, let's get started with today's class. So today's class was is going to be kind of short and sweet compared to the other videos, because the first half of the class, what we did was we discussed the chapter review for your test. However, there were some concepts in section 2.2 that were not discussed. So, what we're going to do now is just go over those concepts. So after we discuss the chapter review, we were continuing with section 2.2, specifically on page 33. And what we did was we defined, or we talked a little bit about weight. So we've heard a lot about mass, and mass is the amount of matter that an object occupies, and then we have weight. The two are very easily confused. And the reason is because when we weigh ourselves, we don't use a balance per se. We use a scale, right? A spring scale. Although now they're digital, but even though they're digital, they still have springs. And the reason is because weight is also dependent on gravity. So I'm actually going to go ahead and define real quick the definition of weight. And weight can be defined is on page 33 of your textbooks. Weight can be defined as a measure of the gravitational pull on matter, as the measure of the gravitational pull on matter. And what that means is that weight is dependent on gravity. And that's why, for example, our weight can vary from one planet to another because each planet's gravitational pull is different. So if we were to talk about weight, and although this is more physics than chemistry, but if we were to talk about weight on this planet, we would use the formula that says W equals mass, right? Whatever the mass of the object may be, times gravity. Now, we're not going to get into this formula because this is seen more in physics class, but this is just so you have an idea of what I'm trying to say. So, if we were to measure the weight of a person on Earth, we would say, well, the mass multiplied by the gravitational constant, and on Earth, gravity, the measurement of gravity is actually 9.8 if we're using meters per second, of course. uh, if you're using the SI system, which is what I'm trying to say, meters per second squared. Okay, meters. Oh, sorry about that. Meters per second squared. Meters per second squared. Okay, so that's the definition of weight, and weight and mass use different instruments to calibrate it. So, if you want to know the mass of an object, you usually use a balance, right? And if you use a weight, or you want to know the weight, you usually use a spring scale. And that's actually that's actually another thing. Another thing says on the same page, page 33, it says, unlike weight, mass does not change on gravity. So, mass does not change on gravity. So, for example, like here on Earth, your weight could even vary from place to place depending on the elevation, right? The closer you are to Earth, of course, it'll vary. It won't be a lot, but it'll vary. But if we talk about your weight on planet Earth and let's say your weight on Mars, to give you guys an idea, obviously the weight will differ because the gravitational pull in Mars is different than the gravitational pull on Earth. However, your mass would not change. Remember, mass is usually given to us if it's a large objects in kilograms, and weight, of course, is given to us usually in pounds, although you can use kilograms as well. Um, Again, weight changes as gravitational force changes. Okay, so weight changes as gravitational pull changes. That's pretty much. Weight can be given to us in pounds, it can be given to us in kilograms. Of course, it all depends on the metric system that we're using, but that's pretty much the most important things, or the most important concepts on page 33. Page 34, we talked about length, okay? So we talked about weight. We know that the mass, or we talked about mass, and we know that mass can be used in kilograms if we're talking about larger objects, in grams if we're talking about smaller ones. And the smaller an object is, the different the unit. Length is another measurement that is used in the SI unit, or the SI system. And it says that the standard unit for length is meters. So the standard unit for the SI standard unit for length is the meter. A meter, so you guys have an idea, a meter is about the width of a doorway. So if you're at home, the width of the doorway is probably what a meter is. Of a doorway. But if we're going to use, if we're going to measure long distances, we use kilometers. And this is commonly used when we talk about, for example, marathons, 5K, 6Ks, 10Ks. The Ks really stands for kilometer. And again, kilometer is, I'm going to write it just the way it's in your book. It says to express longer distances. This is on page 34 of your textbooks. To express longer distances, the kilometer is used. The kilometer is used. And 1 kilometer, which is expressed as km, equals 1,000 meters. Now, this may seem a little hard, 1,000 meters, I'm sorry. This may seem a little hard for us because the system of measurements that we're inclined to using is not the SI. And we don't measure distances, long distances in kilometers. We measure them in miles, and 1 mile is about 5,280 feet. But if we go to other countries around the world, Europe, Asia, a lot of places in Latin America, they use this system. So if you go to, I don't know, I like to use Latin America a lot, but let's say you go to Colombia, and you weigh 100 pounds here, and when you go to Colombia, you might weigh 50 kilos, and you think to yourself, well, I lost weight, but the reality is that it's the same weight, it's just the units that they use is different. Okay, so this can be a little confusing for us. And now we're going to talk a little bit about derived units. And when we talk about, after we talk about derived units, we're going to go into density and volume, okay? Okay, so derived units. Let me erase this image. Derived units. Derived units are basically combination of SI base units. and are obtained or are produced, it's not to go too far from your book, are produced by multiplying or dividing standard units. Or dividing standard units. Okay. For example, area is an example of a derived units. Area, and for example, area is a derived unit. Length times width is both length and width. And we'll talk about area, mainly area of rectangular spaces. It's a derived unit because it's length times width, especially if you have a rectangle. If you have a rectangle, then of course, um, the area of a rectangle is a derived unit because you have to obtain the area of a rectangle. To obtain the area of a rectangle, you have your length, which is here, and your width, which is here, and area, especially of a rectangle. Now, I'm not going to use any other figures because that can vary, especially if you have a triangular figure or a circular figure. But in a rectangular space, this is an example because area equals length times width. Area equals length times width, all right? And that's another example of, or that's an example of a derived unit. So real quick, we're going to talk about, so what your book is saying is that basically, um, basically all of the SI units that you have are pretty much, the derived units are pretty much the base units that are either multiplied or divided by each other, and you have area, and the area can be usually used as meters squared or centimeters squared. It depends on the units that they give you. So if you look at in your textbooks, you have a series of derived units that are commonly used. Now we're going to talk about real quick the about volume. Now, volume, we've already mentioned it in previous classes and videos, but I'm going to define it one last time. So let me actually clear the drawings and have the whiteboard ready for you guys. Let me open up a text box and we'll talk about volume. Now, volume is defined as the amount of space occupied by an object. Okay, so volume, it says, if I am not mistaken, on page 35 of your textbooks. Yes, page 35. I'm sorry there. I'm just making sure that I'm quoting or the right page. So page 35, volume is defined as the amount of space occupied by an object. Volume is the amount of space occupied by an object. How much space does an object has, okay? And it says that the derived unit or the derived SI unit for volume is, and that's also very important, the derived SI unit for volume is cubic meters. And cubic meters is cubic meters. Cubic meters is represented as this. So cubic meters is represented like this, m cubed. Okay, so that's the SI unit for derived SI unit for volume. It says 1 cubic meter is I'm sorry, 1 cubic meter is equal to the volume of a cube whose edges are 1 meter long. Such a large unit is inconvenient for expressing values of materials in a chemistry lab. Instead, a smaller cubic centimeter is often used. There are 100 centimeters in a meter, so a cubic centimeter it contains 1 million centimeters. Okay, so what it's saying is that although for volume we use meters cube because in the volume, and I'm going to try to draw up the cube. I guarantee it's not going to look the way I want it, but hopefully it'll work. So when you have a cube, so when you have a cube kind of like this one, just imagine this is a cube, guys. Use your imagination, do your best. But the cubic meters comes from the measurement of the lengths of the dimensions of a cube. But the problem is that cubic meter is a very, 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 very big unit to use in the chemistry lab, especially because chemists deal with a lot of small components. So sometimes they'll use the cubic centimeter instead of the cube. All right. So that's what the paragraph is actually stating. And then you go in figure 2.6. It says comparing liquid volumes. Well, actually, no, excuse me. That's another thing. I apologize for that. So after we're done with the volume, it says when chemists, excuse me, measure the volumes of liquid and gases, they often use a non-SI unit called the liter. So to measure the volume of liquids, we don't use our chemists use the liters. To measure the volume of liquids, the SI the unit, because it's a non-SI unit, then the unit used is the liter. Okay, the liter. Is the liter. So to measure the volume of liquid, it's usually the liter they're using. You see this a lot in like, when you buy milk or when you buy drinks, right? You'll see them measured in liters. It says the liter is equivalent to 1 cubic decimeter. Thus, a liter is also equivalent to 1,000 cubic centimeters. Another non-SI unit used is the milliliters. Milliliters is used for smaller volumes. So milliliter is also used to measure volume of liquids. To measure volume of liquids. Milliliter is used to measure volume of liquids, but in smaller quantities. Or smaller liquids that occupy less space. And milliliters is used a lot, for example, in medicine, especially with young children, or medicine in general, because obviously it has to be a small amount of whatever medication needs to be administered, because if they would administer instead of milliliters, they would measure that in liters. It could be very harmful for a person. So that's an example. That's a little bit of what meters are. I'm actually now going to go to page 36 and we're going to talk about density. All right. And after that, I'm going to explain the problem on page 38. And after that, you should have enough information for you guys to actually do your your assignment for the class. Okay. So let's talk about density. Density can be defined as the ratio of mass to volume. Is the ratio of mass to volume. Density is a measure of mass to volume or mass divided by volume. And this is used, is the ratio of mass to volume or density, can also be explained as, and your book says another that density is the ratio of mass to volume or mass divided by volume. So the most common way that you see density represented in science, chemistry, and physics is that D, which represents density, equals mass over volume, or DMV, right? And density is used because, and again, this is very important, and let me actually write it down. It says that different substances contain different masses per volume. Okay, so different substances contain different masses per volume. For example, you have liquids. Liquid mercury is a lot, thicker than water, so hence um, it would occupy more space. It would have greater volume. So in that case, it would be denser. And it says density is a characteristic physical property of a substance. So here are little things about density we're going to talk about. Density is a physical property of a substance. Physical property of a substance. Secondly, let's see. Secondly, I'm reading from your book on page 36. It doesn't depend on the size of a sample, because as the mass of a sample increases, its volume increases. Okay, so density doesn't depend on the size of a sample. It doesn't depend on the size of a sample, okay? Because as the mass of a sample increases, its volume increases. Because I already wrote that. because as the mass of a sample increases, its volume increases. Increases its volume increases. So basically, it's saying that liquid mercury is going to be denser than water if we use those two, because as the mass of the liquid mercury increases, so does the volume. That means that the more mass it has, the more space it occupies. It says therefore density it okay, excuse me, its volume increases proportionally. The ratio of the mass to volume is constant. Therefore, density is one property that can help to identify a substance. So, density is a property that can help identify a substance. That can help identify a substance. So those are three important characteristics or facts on density. Okay, so now we're going to talk about the mathematical aspect of density. So again, density is a physical property of a substance. It doesn't depend on the size of a sample because the mass of, and I just realized that I misspelled of, the mass of a sample increases its volume, or excuse me, density. It doesn't depend on the size of a sample because as the mass of a sample increases, and let me put little commas here so you guys understand that's because as the mass of a sample increases, its volume increases. And finally, density is a property that can help identify a substance. So those are some important things that you'll find about on density on page 36. And now let's go to the math part. 37, excuse me. This is on page 37. Let's go to the math part, which is what you're going to do in today's work. And it's the problem on page 38. To be more specific, it is a practice or a sample practice. It's sample problem A. So let me go ahead and I'm doing sample problem A. Sample problem A. A on page 38. So let me type the problem up. Okay. And the problem says a sample of aluminum metal has a mass of 8.4 grams. A sample of aluminum, I'm get your aluminum metal. And I'm actually going to write the chemical symbol for aluminum, which is actually Al. So if you see that, that's just um, the chemical expression or the how it's expressed in the periodic table. It says a sample of aluminum metal Al has a mass of 8.4 grams. Of 8.4 grams. 1 second, ladies and gentlemen. I apologize for the delay. But we should be rolling in a second or two. And okay, yeah. So has a mass of 8.4 grams. The volume of the sample is 3.1 cubic centimeters. The volume of the sample is 3.1 cubic centimeters. Cubic centimeters. Cubic centimeters. Calculate the density of the aluminum. Calculate the density of the aluminum. Okay. Calculate the density of the aluminum. It says a sample of aluminum metal has a mass of 8.4 grams. So we know that the formula for density is D equals M over V. So let me write that down here. D equals M, which is mass, over V, which is the volume. So what we want to do, and of course you're going to need a calculator for it, is we want to just identify what we have. It says a sample of aluminum metal, Al, has a mass of 8.4 grams. So I know the mass is 8.4. So I'm going to write that here, and that'll help me see the information that I have and be able to plug them in. 8.4 grams. And it says that the volume is 3.1. There's a mistake there. It's not 3, it's 3.1. I just realized that I didn't write that in the problem. It has a volume of 3.1 centimeters cube. Okay, so the volume is 3.1 centimeters cube. So that's how much space it occupies. So V is going to be 3.1. And again, you can go to page 38 of your textbook. It's at the bottom of page 38 and it says sample problem 8. So 3.1 cubic centimeters. That's the volume. And the problem is asking me to calculate the density. So I'm missing D. Now this problem is pretty straightforward. It's pretty much telling you what you need to plug in, and all we need to do now is just basically substitute and calculate. Now, if we look at the book, your book just pretty much, so you're just pretty much going to plug everything in. Let me use a different color because this is the part where I'm actually going to solve the problem. So let me use, first of all, let me change to this. And let me see what color I can use. I'm going to use blue. So now I'm actually doing the problem. So D, which is what I'm looking for, is M over V, and I have the mass. And the mass is 8.4. So we're instead of writing M now, you're going to write 8.4. grams, of course, because that's the unit that was given to us. And volume, instead of writing V, I'm going to change that to 3.1 because that was what was being asked of me. And it's, of course, centimeters cubed. And the next thing you want to do is you're going to get your calculator and you're going to divide that. Of course, this is because it's chemistry. If this were math class, I would not allow you to. But you're going to divide in your calculator 8.4 by 3.1. And your answer should be 2.7, more or less. So we say that D equals 2.7. 2.7 grams over centimeters cubed. Again, ladies and gentlemen, all I did was I got the information from the problem. They gave me the mass, which is 8.4. They gave me the volume, they gave me the mass of the sample, which is 8.4 grams. Then the story problem also gave me the volume, which was 3.1 centimeters cubed. The formula, what I need to calculate is my density. The formula is D equals M over V, where M would just be substituted by the mass, which is 8.4, and the volume, which would be the V, is substituted by 3.1. I divide this in a calculator. So in your calculator, you divide 8.4 by 3.1, and your answer is 2.7 grams over centimeters cubed. And that's how you do that exercise. And what you have assigned on your LMS is go to page 39 of the textbook of section 2.2, and you're going to, and excuse me for 1 second while I find the page myself so I can be more specific. Page 39 of your textbooks. I'm sorry, not page 39, page 38. You see, that's why I wanted to make sure that I was doing the right thing. So you're going to go to page 38 of your textbook, and you're going to answer problems 1 and 2. Okay, problem number 1 says, what is the density of a block of matter that occupies 310 centimeters cubed and has a mass of 853 grams? That's problem number 1. And problem number 2 says diamonds has a density of 3.26 grams over centimeters cubed. What is the mass of a diamond that has a volume of 0.351? So let me give you an example of how you would work with a problem like that. Obviously, I'm not going to do that one, but I'm going to use a similar one. So let's say that we have the mass of an object, the density, and we'll say that the density of an object equals 5.4, grams over centimeters cubed. Okay, and this is the density, grams over centimeters cubed. And we'll say that the volume is, I don't know. You know what? We'll use the same one as aluminum. So we'll say that the volume is 3.1 centimeters cubed. Okay, 3.1 centimeters cubed. Centimeters cubed. So we're actually using aluminum. We'll say that the volume of aluminum is 5.4 grams over centimeters cubed, and the volume is 3.1 centimeters cubed, and we need to find the mass. Wow, let me erase that. We need to find the mass. Okay, so let's try that again. The mass. We're looking for the mass of the object. So what we're going to do now, is just plug them in. Again, this is aluminum. And we know that the formula is D density equals mass over volume. So all we really need to do is plug them in. So we have our density, which is 5.4. So I'm not going to write the units right now. Well, yeah, I can write the units. So 5.4 is the density, grams over centimeters cubed. Grams over centimeters cubed. Grams over centimeters cubed. We are looking for our mass, so we don't know what that is. So we'll just leave it expressed as M. And the volume is 3.1. Now, this one is not in your textbooks. This is just me bringing a similar example to the one that you're going to see in the practice problem. So that way you guys know what to do. And of course, centimeters cubed. So if I want to solve for mass, this is like an algebraic equation. So if I want to solve for mass, that means I have to get rid of the 3.1. And I'm dividing m over 3.1. And the way I eliminate that is by multiplying both sides by 3.1. Okay, so I'm going to actually just multiply this side by 3.1. And I'm going to also multiply this side by 3.1. 3.1. And of course we have, centimeters cubed, excuse me. Let me include those units, and you'll see in a minute why it's important that we include the units. And this is centimeters cubed as well. So just like in algebra, this side would cancel out. So this 3.1 cancels out with this 3.1. And then in my calculator, I have to multiply 3.1 times 5.4. 3.1 times 5.4. So you multiply 3.1 times 5.4, and your mass is 16.74. Okay, so I multiplied 3.1 times 5.4. My answer is 16.7 or 16. Yeah, I'll leave it at 16.7. 16.7. And that's going to equal the mass, right? That's going to equal m. So now what happens to the units? Well, centimeters cubed is going to cancel out with centimeters cubed. So that means that my answer is going to be in grams. So 16.7 grams is the mass of this sample of aluminum, ladies and gentlemen. And again, you're going to find these exercises or the two sample problems on page 38 of your textbooks, how to calculate density. I hope that this video, along with the other the highlights that I went over, the concepts that we had that in class that I went over, is helpful. And I will see you in your next class. So stay safe and bye-bye.